Several of the participants in the project are the CDC, of course, the Association of Public Health Labs, and several states. It's been truly a collaborative effort. It's been a team effort. It's been a hard year, but as you will see in the next few slides, it's been a very successful year. Some of the team members are here from Florida, from Texas, Nebraska as well. And I'd like to take the opportunity before we begin the presentation to give everyone a round of applause, the team members. Okay, so FLIP. How many of you here today are participating in FLIP? Hands? Hands? How many are not and want to participate in FLIP or are interested in FLIP? Okay, very good. The Public Health Laboratory Interoperability Project, otherwise known as FLIP, founded by the CDC and the Association of Public Health Labs, has had the goal of creating tools for the exchange of lab data at all levels of public health labs. The vision of FLIP is to achieve bidirectional laboratory data exchange focusing on the state public health labs with the CDC in addition to partners within the state. There are obviously many benefits to this project, and some are to improve the data quality and accessibility, to improve the data sources for active surveillance, and to develop and test future system approaches. Some of the building blocks of FLIP are to implement a binational collaborative process similar to this project where you have multiple states, multiple agencies, and multiple people involved. And one of the benefits, of course, that I like is to develop and pilot a data exchange architecture, which is what we're going to be talking about today. Some of the support services offered by FLIP. One of the support services and projects is obviously the Route Not Read project for regional exchange. It's actually an interim solution that can grow while we wait for PHIN MS 3.0, and one of the speakers today, actually the last speaker, will talk about PHIN MS and the future roadmap. Another project, the Pandemic Influenza Project, we have Texas here, for example, who's involved in that project and is working parallel with the RNR group in moving forward electronic exchange. So FLIP has several use cases. Of course, one of them being the Route Not Read hub. And I like this slide because it talks about the different phases of the overall project. And let's go over those phases. Phase 1 was to implement the hubs in Nebraska and Florida. Check mark. Phase 2 was to develop hub-to-hub interoperability. Check mark. And phase 3 was for the CDC to develop capability to exchange messages with the RNR hubs. And as of last month, check mark. So it's been a success, and I'm very proud to be able to stand here and state that, that excellent work. So PHIN MS. As you know, we'll have more discussions throughout this session about PHIN MS, but a few key points that the PHIN MS team, who have been very helpful through this project, shared me to share with you. It's the foundation of the RNR hub. Okay, it's the CDC-sponsored open source messaging solution, and many of you use it today, I'm sure in different ways. And for those that don't, it's important to know some of those benefits. It's secure and reliable, standards-based, available at no cost, which is important. It's the de facto standard for secure message transport. There are several applications using it today, like ELR, LRN, and several others. Some of the states are even using it internally, like the state of New York, like the state of Florida. It's used, as we heard yesterday in the PHIN certification session, for PHIN certification. It's one of those requirements. It's a 6-year-old product, which I think is very interesting, and it's deemed mission critical by the CDC. And, as I was talking to one of my colleagues today, there are over 700 PHIN MS nodes in the US. So we've got the direct send model. That's the typical model that I think most of the users here of PHIN MS use. It's basically, it's a single sender to a single receiver, which is, it was mentioned yesterday in the PHIN certification by a gentleman that he compared it to FedEx, where you've got a package, you wrap it, you send it, similar to PHIN MS, and it's acknowledged at the end, similar to a FedEx package, which I thought was an interesting analogy. Some examples of the direct send model are your state public health lab, sending influenza tests to the CDC, which I know many of you use. or a private lab in your state, sending to your state public health lab. It's another use being used today with PHIN MS. The direct send model is functional. It's actually a very good tool, as we know. However, as the network exchanging of information grows, it could pose challenges, as you will see in the next few slides. This graphic was created by John Butler. All right. So here in the direct send model, each direct connection requires certain efforts to set up and maintain. Infrastructure needs, resources, which we all have to deal with on a daily basis. As you can see in this slide, it can create a web of connections which can grow exponentially, potentially also growing your efforts, resources in your integration team or your IS team. Okay. All right. Several points to consider with the direct send model. Each node exchanges their credentials with every trading partner. Each node manages the trust relationship with every trading partner. And adding a new node to the community results in exponential growth of direct connections and maintenance. All right, let's talk about the route not read model, what I'm here to talk about today. What we've been working on over the last year is the route not read model, and the foundation is still PHIN MS, and that's important to understand. As you can see in the illustration, you can have two partners, as a sender and a poller, exchanging data via a hub. In the case of this pilot project, the two hubs are Nebraska and Florida, and we have representatives from both teams here today. This illustration shows the RNR hub with 5 partners that are both sending and polling. One of my colleagues, a data integration engineer for the Department of Health, likes to use the analogy of an Exchange email server. Someone sends you an email, it sits on the server until you receive, or in the case of the RNR hub, it polls from the server. An interesting measure that I must emphasize is that in the RNR hub, there is a parameter that does not allow actually the hub to read the message. And it's one of those questions that we get often asked is, what happens with the message when it gets to the hub and it's waiting in queue? Well, it's not read, it's just waiting for the receiver to poll. This is actually my favorite illustration. I have 2 favorite illustrations. This is my first one, and you'll see why I mentioned that towards the end. This is where you have 2 hubs. You've got Nebraska and Florida, and the interoperability piece that we've been working on comes into play here. For example, Colorado, a partner in the Nebraska hub, wants to send to Virginia, which is actually a partner on the Florida hub. It can do so with the work recently done in terms of interoperability, which we will get into in the next few slides. All right, some of the benefits. PHIN MS receiver is not required for bidirectional messaging. Additional firewall configuration, for example, is not typically required for each trading partner. It facilitates rapid implementation of electronic message exchange. Costs are lower. We have install package, documentation, and manuals. For example, after this presentation, if someone is interested in becoming a hub partner, we have those documentation in place to facilitate and make this a seamless process. Interoperability. As mentioned a few slides earlier, one of the key pieces to the work accomplished over the last year is interoperability. The team focused on assuring that not only can partners communicate with each other, but that Nebraska and Florida, the hubs, can communicate with each other. This piece of the project goes back to the collaborative effort that I mentioned earlier, where all the RNR team members participated, shared, suggested ideas, made recommendations, actually made a visit to Florida where for a week we tested in our lab environment, and we're very successful in interoperability testing. So what type of interoperability? What did we use? What was the design? Web services was designed, tested successfully. 2 of the main benefits are synchronization of users. For those that use PHIN MS, and I know our friends from the CDC understand this, party IDs, usernames, keeping those documented. Synchronization is in place for that, as well as audit trails for status messages on the local and remote hubs.